In this video, we're going to go on to example 5 in chapter 2, section 5. And here we have what I call a motion problem. And motion problems are basically set up around the formula distance equals rate times time. So Frank drove a steady speed of 3 hours on the turnpike. He then slowed his traveling speed by 15 miles per hour on the secondary roads. The entire trip took 5 hours and covered 245 miles. What was his speed on the turnpike? What was his speed on the secondary road? So we have two things we're looking for. X is the speed of the car on the turnpike. Y was the speed on the secondary roads. Now we are told a few things. Again, we have three different quantities we're interested in here: distance, rate, and time. So the two quantities that we're looking for are the speed, which are the rate on the turnpike, and the speed on the secondary roads. We know a couple of things here. We know that um, the whole trip took 5 hours, and 3 hours of that time was spent on the turnpike. That must mean that 2 hours were spent on the secondary roads. Now, we know something else here. We know that the speed on the secondary roads was 15 miles per hour slower than the speed on the turnpike. All right, now we're ready to do something here. We're going to use the total distance traveled. We know that the total distance traveled is 245 miles. Well, there are two parts to the trip. There's the part on the turnpike, and so there is a distance traveled on the turnpike. And then there's a distance traveled on the secondary roads. And when you add those two distances together, you should get the total distance traveled. Now, how do we make up the distance traveled on the turnpike? Well, distance equals rate times time. The rate on the turnpike is x. The time was 3 hours, and so we have 3x for that. The distance traveled on the secondary roads would be rate, y, times time, 2 hours. But we can also write that as, well, let's write it as 2y, and then we know another name for y, or another way to express y, and that is as x minus 15. So now we have one equation with one unknown, and we're ready to solve. 3x distributing the 2, we get 2x. 2 times negative 15 is negative 30, equals 245. Combining like terms, 5x minus 30 is 245. Adding 30 to both sides is going to give 5x equals 275. Dividing all sides or both sides by 5, and we get x is equal to 275 divided by 5 is 55. So that means that the speed on the turnpike would have been 55 miles per hour. And you recall that the speed on the secondary roads was 15 miles per hour less than that, so that should be 40 miles per hour. And we're just going to check our results here to make sure we got everything correct. How would we do that? Well, 3 times 55 gives us the distance traveled on the turnpike. 2 times 40 gives us the distance traveled on the secondary roads, and that has to come out to be 255. 3 times 55 is 165. 2 times 40 is 80. And again, we want to check to make sure that would be 165 plus 80 is equal to, that's 245. Sorry, I said it should be 255. Actually, that's a mistake. There it is there. should be 245. And 245 equals 245, and so it does check out there. So again, I made a mistake there in the check, and since it didn't come out correct, I looked for what happened, and I found that I just wrote the number incorrectly there. All right, we're going to go on to the final example of this type. Student practice 5. Wally drove for 4 hours at a steady speed. He slowed his speed by 10 miles per hour for the last part of the trip. The entire trip took 6 hours and covered 352 miles. How fast did he drive on each portion of the trip? So recall, our basic formula here is distance equals rate times time. We have two parts to this trip. We have him driving 4 hours at a steady speed and then slowing his speed by 10 miles per hour for the last part of the trip. So now one way that people have solved this problem is to set up a little table like this, because there are two parts to the trip and we're going to have a distance, rate, and time for each part of the trip. So if we call this the first part and this the second part. Now, what we do know is that the entire trip took 350 or covered 352 miles. So we're not going to put that 352 in either of those, but it will be the total is 352. The second thing we know is that the total time was 6 hours. And we do know also that Wally drove 4 hours on the first part of the trip. That must mean that he had to drive 2 hours on the second part of the trip. Now, we don't know about the rates. However, we do know that on the second part of the trip, he reduced his speed by 10 miles per hour. So instead of writing y here, I can just simply write that the second rate was 10 miles per hour less than the first rate. And then all I need to do here for distance is rate times time. So that would be 4x, and the second part of the trip would be 2 times this quantity, x minus 10. And now I have an equation that I can set up and solve, and it goes like this. 4x, which is the distance traveled on the first part, plus 2 times x minus 10, and that quantity is the distance traveled on the second part of the trip, has to equal a total of 352 miles. We're simply going to multiply out here. When we do, we get 4x plus 2x minus 20 is 352. Combining like terms, we get 6x minus 20 is 352. Adding 20 to both sides, we end up with 6x is equal to 372. Dividing by 6, we get x should be equal to 372 divided by 6, or 62, which should be the miles per hour driven in the first part of the trip. And so let's write that in there. And if the second part was 10 miles per hour less, then that should be 52. So let's go ahead and check our results to see if we got it right. 4 times 4 hours at 62 miles per hour plus 2 hours at 52 miles per hour. We want to know if that adds up to a total of 352. 4 times 62 is going to be 248, and 2 times 52 is 104, and that does indeed equal 352. And so we do get the same value on both sides. And so this is another way to set up a distance, rate, time, or a motion problem. So in these sets of problems, we've learned 3 very important problem types. We've learned some percentage problems, or actually 4 types. Some percentage problems. We have done some interest problems, putting money into 2 different accounts. Next, we've done some mixture problems where we're mixing 2 amounts from 2 different quantities and coming up with a final product that is a mixture of the 2. And then we have these motion problems. So it is important to study these 3 or these 4 different types of problems. Actually, we have 5 different, but some of them are related. And to make sure you understand how to set up and how to solve these various types of problems. So that'll do it for this.